Good morning, everyone. Welcome back from the long weekend. Um, yeah, excited to get back to webinars. Today we have a pretty good one. We're going to be talking through building enterprise scale feature stores with on Databricks with Featureform. And there will be time for questions at the end. This will be a recorded session, so we will be sending it to people. I know a few people asked for it. And yeah, excited to get going. So I'm going to start by sharing my screen. Okay, let's jump in. So when we first learn machine learning, when we first take that Coursera class or whatever, we're always taught to use, the simple framework where features are columns in the CSV you're provided, they're perfect and easy to use, and then all your time is being spent on the model. So you're building different types of regressions, etc., on the model that use those features. And we spend a lot of the time really focused on the model piece. Now, reality looks very different. In reality, most of our time is actually spent in the data side. And the complexity of managing all of that across different people, across different data sets, across messy data sets that exist, across enterprise access control, rules, governance, etc., it can really quickly become chaotic. So that's kind of the premise of why MLOps was created. This is why MLOps exists. MLOps is the techniques and practices that we use to make it possible to work as a team on huge data sets, building lots of different models, and working in a very iterative way with a good feedback loop, etc. So we're going to go into that. But specifically today, I want to focus on one key component of the ML lifecycle that we often don't touch on enough, which is the data. Um, when we think of the data part of the model, all of our data first begins in data sources. So we have maybe files or tables or whatever strewn about that we work off of. Typically, there's some set of transformations, and it's not usually just one, as we see here. It's usually like a DAG, a set of them that creates a lot of the different data sets that we can use from. Some of those data sets contain columns that we use as features for training. Those go into here, what we call a training store. And then other ones go into the inference store. So breaking it down maybe more piece by piece, we have raw data. We transform it with some set of transformations. When the data is created and transformed, we'll typically first put it in a training store. A training store will allow us to get all the features values over time so that we can actually train a model on those features. And also, we will cache the most recent value of each feature in an inference store. And that allows us to be able to quickly look up pre-processed features at serving time. So if we have models in production, we can really easily and quickly get what the feature values are. For example, if you're Spotify and someone enters their Spotify and it's making recommendations for you, rather than processing features based off of all of your listens ever, likely what's happened is most of those features have been pre-processed, and all it's doing is it's grabbing all of your features and it's making a prediction or a recommendation at that moment. So these are the components that make up the data piece of the ML lifecycle. But underneath it all, it's important to say, is it's all still on infrastructure. So in the end, this is all running on, in this example, S3, Spark, Redis, Bo. It might be very different depending on where you work and what your stack looks like. There's a lot more to it that I'm not really getting into specifically in this piece. Like there's governance, there's monitoring, there's versioning, lineage. There's a lot of different components that also come into play, but these I would say are the fundamentals. If you don't have these pieces, you can't really train and then deploy a model to production on your data. Now, one category of MLOps that's often kind of pitched as a solution to data problems are feature stores. And that's sometimes met with some confusion, mostly because of the name feature store. When you think of a feature store, you think of a database where features are stored. However, if you look at this again, the storage piece, like the inference store and training store, is important. It's very important, but is actually only a small piece of the puzzle. If you don't tie those things to the transformations and the data sources themselves, and it's your job to handle and build all those, then you're not even solving half the problem. So, in my opinion, to really have a feature store, so nowadays people call it like a feature platform, you really need to give a data scientist something that allows them to work on data from end to end, from the raw data all the way to the features that go into the model. And so the feature store actually wraps this whole bit for the ML workflow. Now, that's not the opinion of all feature stores. There's actually three categories of feature stores that kind of have, or architectures you could say, that kind of have come to exist. The first kind, I'll call the literal feature store. So the literal feature store is very similar to what I just described in the sense that it's literally storing features. This is the pattern that like the Databricks feature store, for example, follows. In their architecture, what they do is that you take your data, you build it, you transform it yourself, and then in the end, you store it in the feature store where it can then be used for both training and inference. To show you this, just to make it a little more concrete, I can actually pull up what the Databricks feature store looks like. And if you look at the Databricks feature store and I click, you'll notice that the Databricks feature store is made up of feature tables. And in each of these feature tables, you get the columns. And within the columns, you just kind of have some metadata that people can add. What you'll notice though, is that you don't actually get lineage. You don't actually know what this feature is, how it was created. If you were to change it or you want to create a new version of it, that wouldn't really be possible in this workflow. And so all that tends to be missing. So going back to kind of this picture, what the Databricks feature store focuses on is the inference store and the training store. It does not handle transformations or data sources at all. It kind of leaves that to the user. This is different from example from Featureform style, where Featureform style, if we look at any of the features or data sets that exist, and here, let's do a more interesting one. Let's do this one. You can see that for each feature, for each transformation, you can get the lineage, you can preview it, you can see other features that exist from here, labels, training sets. You get way more than just the very simple, here's a table with some columns. So that's the literal feature store. The literal feature store is literally a place where features are stored. Featureform, like I kind of started alluding to, has a different approach. The Featureform approach doesn't define a feature as a table. Rather, it defines a feature as the logic that builds that feature. So it's like the transformation is the feature itself. So the SQL logic is stored. Featureform orchestrates it on your existing infrastructure, and that is actually what makes up your features. So it's a big difference in how we think about things, and it's not just conceptual. It's not just like, oh yeah, like features are defined either as tables or as SQL strings. It fundamentally changes how you interact with the feature store. Featureform, the name Featureform, It comes from, or it's kind of alludes to Terraform, which is a declarative way to define your infrastructure. So Featureform is a declarative way to define your features. So the problem it's solving and the way it's solving it is completely different from just treating it as, hey, here's a sink for your data, build your features, just put them in this special storage layer. By doing so, it makes it possible to do versioning, lineage, share and reuse, because we have all that stuff. Also, because we have the underlying data, and you can see how the data is, or all the features are actually being built. It's easy for us to understand data drift. We can orchestrate these things. So it's not. So if you are dealing with streaming data or huge volumes of data, you can kind of offload a lot of that work to Featureform itself. It will handle building that stuff. So as a data scientist, you can just worry about providing the correct SQL logic, and you don't have to depend so heavily on your data engineering team to actually put those pipelines in production for you, to manage those, to maintain those, and vice versa. As a data eng team, you don't really have to be always building pipelines that may or may not be used for data scientists for them to iterate on their models, which is one of the key values of a feature of feature store. So if we were to take our definition of a feature store, the virtual feature store, the 5 value props that tend to arise from using it are these 5: facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. So first is facilitating deployment. We talked a bit about how in reality, a lot of building features actually comes from interacting with our data sources, building transformations, deploying data pipelines so that we could actually get those features in production. The problem that arises is that we have these like perfect features in our notebook. In our notebook, when we're experimenting, we're allowed to use pandas, we're allowed to work locally, and it's just easier. But when we have to get to production, we suddenly have to start worrying about changing data. We have to worry about uptime. We have to worry about scale. There's a lot of things that come into play in production that are quite different and can actually be huge blockers from us being able to get our features in production and iterate quickly. There's kind of this like fence between production and experimentation. And the reason for that is, like I mentioned, the data is changing. And because the data is changing, it's not this like static sample that we grab and can work with locally. We might have to deal with streaming features. Even in batch, we might want to do incremental processing, or at least you want to have like a really good scheduler. You want to understand when things are changing, have correct data drift. You want to catch issues. There's just a lot of things that come into play that are different. There's also situations where the data that we are building features on, we don't even have in storage. It comes with the request. For example, if you are dealing with like fraud and you are dealing with like a transaction to see if it's fraudulent, you won't have the transaction until inference time, which means that the featureization of that transaction has to occur at inference time. So the logic there is going to look very different from like a SQL query in Snowflake or something. So it's just you're fitting into this data flow that is far more complex than just here, grab a sample and do whatever you want in your notebook. You kind of have to fit it into the production data pipeline deployments. And that's a big jump from what we do in experimentation. The way we see it done in practice is in one of 2 ways. Either data scientists themselves are tasked with figuring out how to get the features in production, or data scientists hand off their messy notebooks to a data engineering team to get them in production. And so in one sense, either the data scientists are kind of tasked with it. And in practice, most data scientists, some are very good at it, but it's not really why you hire data scientists. At least it's probably the wrong job description. That's more of a data engineer's job. So you can have data scientists who are good data engineers, but it just makes it much easier if data scientists can focus on what they do well, which is the data science. On the other end, you can have that be true and have this like separation of data scientists and data engineers. The problem here becomes that data scientists become completely dependent on data engineers to actually get their models in production. And data engineers spend a lot of time working and productionizing data pipelines for data scientists. Now, the other problem there is that lots of features are inherently experimental. They may or may not work. They may be changed. They move really quickly. They change very quickly. It doesn't really fit a data engineer's workflow, which is very oriented around metrics, which are things that shouldn't change very quickly and are much more, are handled with much more care than perhaps a feature might be. So our view at Featureform is that we need a way to enable data scientists to do it themselves, but make it easier. Don't force data scientists to become data engineers. Kind of give them a prepackaged harness that they can just give their code to, because they're fully, every data scientist I know is happy writing SQL or data frame transformations. It's the productionizing, dealing with different like streaming data, different modalities of data. That's where it starts to get really messy, and that's where things like Featureform can help and be that harness to handle that for them. Once those features are in production, that's not really the end. A lot of people think of, okay, cool, I've got my feature in production. Good, it's being used by a model. You see a lot of the companies that have thousands of features in production, but no one can really tell you which features are being used where. They're not really well documented. You just have these deployed pipelines where no one can really see who's using them and how they're being used. You also end up with situations where you have dependencies that no one knows about, where you're using a table to power your feature, but the person who made that table is not aware that their table is being used to actually power this pipeline. And in a nutshell, like if I was to take all of the problems I see and put into one slide, it would be this around experimentation and organization, which is that people, once you get your features in production, to get it there, you end up with a ton of garbage that gets generated, from untitled notebooks to badly named variables and tables to ad hoc scripts that we run. And then finally, all of this being relatively undocumented. You kind of are dependent on finding the people who did it, hoping they remember it, and working with them to try to iterate on these things. The other piece of the post-deployment that is often neglected until it becomes a huge problem is reliability and monitoring. Once features in production, especially in true prod, unlike experimentation, in experimentation, the data doesn't change, right? You just have a sample, you trained it, you can see how the model did. In production, things change all the time. Things drift. Now, the model in practice should be able to generalize a bit. I mean, if it's a good model, it should be able to generalize. But there's always limits, and there will always be edge cases and things that happen that can cause the model to misbehave. If you don't have monitoring on these things, you just won't know when this is happening, and so it will cause issues for you. Finally, there's preserving compliance. Well, preserving compliance, that's where you start thinking about governance, access control. If you're dealing with an enterprise deployment, this stuff comes up all the time. So I'm not going to go too deep into the governance piece, but I do want to now maybe show some code, make it seem, I've talked a lot about the theory of everything. I want to show you how it actually looks like in practice. So here I have a very simple Featureform script. The first thing I did, like I mentioned, Featureform runs on existing data infrastructure. So we're not actually being our own transformation engine or storage engine. Rather, we're grabbing Spark in this case. We're registering files to it. Everything in Featureform can be retrieved and used as a data frame. So it makes experimentation very simple. Now, like we said, this is just the first piece. This is just registering transformations, registering your primary data sets. A lot of feature engineering is building transformations. And in Featureform, that's very simple. How you build a transformation in Featureform. So we support both SQL and data frame transformations. But what you do is you take your transformation, you put it in a function. This function is annotated with a little bit of metadata, where it runs, what kind of transformation it is, maybe any inputs it has, and perhaps other metadata you may have. When this is done correctly, it properly builds your transformation. So this becomes something that's usable both as a data frame and it becomes a production grade pipeline. So it's continuously updating in production. This is something that if it works, you can very quickly flip a switch and start using in prod. So that separation between experimentation and production kind of goes away. It becomes much simpler to reuse your features in both places. You can get way more complicated with your transformations. You can do window transformations, you can do streaming data, you can do all kinds of different things. You can then build your training sets. So training sets are very simple. You just specify which columns of those transformations become features, perhaps which one is a label, how they come together into training sets. So a training set is a label and a set of features. And when it's applied, all those things become visible in the Featureform dashboard so that you can see those transformations as training sets, etc. Now, that's not the end, right? Like once you have a training set, that's great, but now we need to use those in actual production. So doing that again is very simple. With Featureform, you can actually grab your training set as either loop through mini batches or just a data frame itself. You can, so here I'm getting a data frame. I'm actually using it with MLflow. And so you can see I'm kind of like tying my my Featureform training set to the MLflow model so that I can actually see in my experiment not only that what happened, but also I can get the lineage all the way from how that feature was created and how that training set existed. Once this happens, all these features are also usable in production settings. You're specifying the inference store as Redis. So when we're training, it will be using S3 because we want to just get all the data very quickly. But all of this stuff also gets materialized to Redis so that it can be used for inference use cases as well. This all comes together to make it really simple for use. Like most of this looks very similar to what a data science would do anyway. But when you think of all the steps that have to be taken to go from this to production, dealing with streaming data, thinking about uptime, thinking about availability, thinking about monitoring, all these other dealing with the data eng team, getting this thing actually deployed in prod, it becomes much more complicated. But with Featureform, a lot of those steps disappear. We kind of have built-in defaults that make it very easy to handle all that. Yeah, so I'm going to stop here. If there's any questions from anyone, feel free to throw them. If you're on Zoom, you can throw them in the Q&A. If you're on LinkedIn, you can throw them into the comments there, and then Marie will be taking a look. And if there's any questions I could answer, I'd be more than happy to. Cool. Any questions you see, Marie?
No questions on LinkedIn.
Cool. Cool. Well, I know we're all getting back, or a lot of us, especially in the US, are getting back from vacation. So I know it's probably, and it's a nice early morning. We will be running more frequent webinars. We'll be doing a lot of different topics soon. If you have any topics that you would like us to talk about or do a webinar on, please don't hesitate to message us and ask, and we'd be more than happy to see if we can get together that sort of content. But otherwise, if you did sign up and you did join, Maria will be sending you a follow-up email with some information about Marie, what you want to take it over and talk about what's going to be in that follow-up email?
Yeah, sure. So the follow-up email, it'll have a recording of this webinar, so you can look back at it whenever you like. It'll also have links to our Slack community that you can join, and you can interact with fellow people in the MLOps community, as well as our team if you have any like specific questions about Featureform. We'll also have links to our docs. And if you're interested in scheduling a demo with us, it'll have links to that as well.
Awesome. Thank you, Marie. Well, thanks
Yeah,
everyone
of
who
course.
joined. And